Hey, hi everyone. Welcome to the next video on design of sequential circuit. In this, I'm going to introduce you to digital counters. Myself, Ganesh, and Naina will going to present you the introduction to digital counters. So let's see what are the learning outcomes of this session. At the end of this presentation, learner will be able to define sequential circuit and digital counters, classify clock signal and digital counters, and identify the clock signal from symbol. Okay, so what are the content of this today's session? We are going to see the digital sequential circuit, then types of digital sequential circuit, then clock signal and triggering, then digital counters, what are the types and applications. Let's see what are the digital sequential circuit. First we will see what is the digital sequential circuit. It produces the output based on current and previous input variable. So this is a very important word in this. It produces the output when the current it produces the output when it is based on the current inputs as well as previous inputs variable. Okay, so it means it requires the previous output also. But how we can store that previous output? Because in the combinational circuit they only give the instantaneous output. So we have to add some element which stores the previous input. So it requires memory. So it includes the memory for storing of the binary information of the previous variable. A latch is capable of storing 1 bit. So we know that a latch can store 1 bit, or flip-flop can store 1 bit. So we can use the flip-flop in case of design of sequential circuit. So see that what is the difference in the combinational and sequential circuit. In the combinational circuits, when you give the inputs, the outputs, corresponding outputs you will get. But in the combinational circuit, the next state is taken into the memory circuit and it is provided as a feedback to the combinational circuit. So memory element is very essential part of the digital sequential circuit. So let's see what are the types of sequential circuit. So there are two types of sequential circuits. One is the asynchronous sequential circuit, and in this asynchronous sequential circuit, so the clock may be provided or may not be provided. Here the clock is given to the first flip-flop. Only the clock is given to the first flip-flop, it is not given to the second. Same clock is not given to the second. The output of the first flip-flop, that is Q0, is the output of the first flip-flop. It is connected to the input of the second flip-flop. Means the clock is not simultaneously applied. That is, output Q0 here, the output Q0 and Q1 will not change its states according to this clock. This Q0 is only dependent on this clock, whereas this Q1 output is depending upon the output of the previous flip-flop, because it is given as the clock. So it changes its outputs according to the output of the previous flip-flop. So it is not working in synchronous manner, hence it is called as the asynchronous sequential circuit. So let's understand what is the synchronous sequential circuits. Okay, so in the synchronous sequential circuit, the same clock pulse is provided to the all. See, the clock pulse which is given to the flip-flop number 1, the same clock pulse is given to the flip-flop number 2 also. Same clock pulse is given to the flip-flop number 2. It indicates that the output Q0 and Q1 changes its state simultaneously. Okay, so because the same clock is provided to the both flip-flop, hence it is called as the synchronous sequential circuit. So what is this clock, or why this is called as a clock or triggering? So let us understand what is the clock or triggering. So to understand the clock or triggering, we know that in digital circuit we are using the binary number. In digital circuit we always use what? Binary number. Okay, to use this binary number means we have to use a 0 or 1. But how we recognize the 0 or 1? 0 means 0 volt output and 1 means 5 volt output. So here I have showing I'm showing one signal to you where sometimes the output is 0 and sometimes the output is 5 volt. So can I say in this duration it is in on state? Okay, and in this duration it is in off state because it is having the 0 output. So this signal is called as the clock. So how we'll define this clock signal? So let us define the clock signal. The clock signal is a periodic signal. So see that this is a periodic signal. Its on time and off time need not to be same. So see here I am showing the on and off time equal, but it is not necessary that on and off time must be equal. But if the on and off time is equal, so what is the duty cycle? How will calculate the duty cycle? Duty cycle is equal to T on upon total time duration T. So T is nothing but a T on plus T off. So if the T on is equal to T off, suppose T on timing is equal to T off timing, then this duty cycle, if you calculate it, it will comes to the 0.5 or 50%. So that waveform, what we call that waveform, that the clock signal is called as a square wave when on time and off time is same, that is the duty cycle is 0.5. In digital circuit, 0 volt represents, so this is very important statement, 0 volt represent the off state and 5 volt represent the on state or high state. Sometimes it is known as the low and high. In digital circuit, the popular word is low and high. Instead of an on and off, they are using the low and high in digital circuit. So hope you understand what is a clock signal. Clock signal is a periodic signal which turns on and off. It not be necessary on and off time, but if it is called as a square wave when on time is equal to off time. 0 volt represents the low and 5 volt represents the high. Let's understand what are the different output when this clock signal is used to operate any digital circuit. When this clock signal is given to the any digital circuit, it is called as a triggering. Okay, so it is called as a triggering because the output is changing with respect to the triggering. Okay, what are the different types of triggering? So mainly there are two types of triggering. One is called as a level triggering. Level triggering is again classified into two categories: positive level triggering and negative level triggering. Then it is classified as a edge triggering. Types of triggering is main types are level triggering and edge triggering. Edge triggering is again classified as positive edge triggering and negative edge triggering. Okay, so here the reflection spot for all of you. Okay, so let's understand reflection spot. In this reflection spot, what is the given? I have given the 4 figures over here. So let me cut this whatever I have written in the previous slide. Okay, I'm giving the 4 signals over here. So this 4 flip-flop. Here the clock pulse is given. Here also the clock pulse is given. But see, here no bubble. Here there is a bubble. Here is only triangle. Here is a triangle and bubble. And this clock pulse is given. So you have to recognize what is the type, which one is the edge triggering, which one is the level triggering, and out of that which one is the positive edge triggering and negative edge triggering. Pause the video for some duration and write down the answer in the paper. Hope you have written the correct answer. Let us discuss the answer in the next slide. In the level triggering, so level triggering means the outputs have some specific level, either it is a 0 or 1, or you can say it is either it is a low or either it is a high. Where it is called as a positive level triggering, if the sequential circuit is operate with the clock signal when logic is high, then that type is called as a positive level triggering. So what is this positive level triggering? Let us understand. This output will change its states. This output of this flip-flop will change its states when the clock is at its higher position. Okay, when the applied clock is high, then the output will be changes its position. Then it is called as the level. It is because it is depending upon the level. So it is positive level triggering. So what is the negative level triggering? In the negative level triggering, we are applying the pulse with the 0 volt. Suppose the 0 volt is applied and the output of the flip-flop it changes, means it is called as the negative level triggering. If the sequential circuit is operated with the clock signal when the logic is low, okay, when the logic is low, because we can say that this logic is a 0 means it is a low, and this logic is 1. When the logic is 0, if the circuit is operating, then it is called as a negative level triggering. Okay, so let's understand what is the edge triggering. Okay, so in case of edge triggering, here I am applying the pulse. So see that the edge in the previous slide, if you observe, in the level triggering, the clock is directly connected here, hence it is called as a positive level. Here bubble is shown. So what is this bubble is indicating? It is indicating that it is a negative level triggering. So what is in edge triggering? In case of edge triggering, if you observe, in case of edge triggering, this triangle is shown. This triangle indicates that this flip-flop is having the edge triggering. What do you mean by edge triggering? When the output is changing from low to high, then output will changes its status, then it is called as a level triggering. Then it is called as edge triggering. When the clock is changing from 0 to 1, at the same instant the output is changing, so it is called as the edge triggering. As the clock is changing from low to high, it is called as the positive edge triggering. If the sequential circuit is operated with the clock signal, that is transition from the low to logic high, then it is called as the positive edge triggering. Let us understand what it is also called as the rising edge, because it is changing from 0 to 1. It is rising edge, so it is called as a rising edge. Okay, what is the next is negative edge triggering. In case of negative edge triggering, if the output of the sequential circuit is changing, sequential circuit is operating when the output changes from 1 to 0, that is when the pulse is falling, then it is called as the negative edge triggering. So observe, here only triangle is shown, here it is a triangle and bubble is shown. It indicates that it is a negative edge triggering. Okay, so it is a negative edge triggering. So let us define what is this negative edge triggering. If the sequential circuit is operated with the clock signal transition from logic high to logic low, then it is called as a negative edge triggering. It is also called as the falling edge. This is a rising edge because it's changing from 0 to 1, output is changing, and here it is from 1 to 0, the output is changing. It is called as the falling edge triggering. Okay, so these are the types of clock pulses and triggering. Let us understand what is a digital counter. So you might have come across various types of the counter. Here one type of counter is shown to you, which is counting something. What is the something means? What it actually counts, that defines the counter. Counter is a sequential circuit, a circuit which is used for counting the pulse. What it is called counting? It is counting the number of pulses, that is a clock pulse. Then it is called as the counter. The counter is the widest application of flip-flop. So the counter is always designed with the help of flip-flop. It is a group of flip-flop with the clock is applied. The clock may be synchronous, clock may be asynchronous in nature. A counter is a device which stores. Okay, so what is a counter? Which stores the 1-bit memory. Okay, stores the number at a particular event or the process has occurred, and often in relationship with the clock. Okay, so this is the definition of the counter. The counter is a device which stores the number of times a particular event or process is occurred, often the relationship with the clock. So what are the different types of digital counter? According to the types of operation, it is called as up counting, down counting, or up or down counting. So what is up counting? When the counting is starting from 0, 1, 2, 3, okay, then it is called as up counting. What is the down counting? Suppose it is starting from 3, 2, 1, 0, down counting. Sometimes we require up down counter, like both combination in the one counter, then it is called as the up down counter. So according to operation, this is defined as up counter, down counter, up down counter. Then according to the number of bits, this is called as a 2-bit counter, 3-bit counter, 4-bit counter. So let us see 2-bit counter. Here I am showing the 2-bit because 0 can be represented with the 0 0, it is represented with 0 1, then 1 0, 1 1. Suppose it count is the number of bits are 2, then it is called as 2-bit counter. Suppose we are going to count from 0 0 0 to 111, then it is called as a 3-bit counter. If we are going to count from 0000 to 1111 in binary, then it is called as the 4-bit counter. So this is 3-bit counter. Okay, this is a 2-bit counter, and this is the 4-bit counter. Okay, so these are the different types of the counter. According to the clock applied, it is called as a synchronous counter and asynchronous counter. We already we discussed in the beginning. If the clock is simultaneously applied to the all flip-flop, then it is called as a synchronous. If the output of the first flip-flop is connected to the clock of the second flip-flop and subsequent flip-flop, then it is called as the asynchronous counter. Okay, then according to the applications, BCD counter means it counts from 0 1 2 3 likewise up to 9. Then it is total numbers they are counting, it is a 10, hence it is called as a BCD, binary coded decimal counter. Octal counter will count from 000 to 111. It is also called as a 3-bit counter. Okay, then n modulo counter, sometime we require, just like a clock, when the clock signal is reaches to the 59 second, okay, 59 second, the next second should be 00, then it is required n modulo counter, because we have to restrict our counter up to the 59, then the next will be output will be 00, then it is called as the n modulo counter. Hexadecimal counter means it is nothing but a 4-bit counter which counting from 0000 to 1111, so it is called as the hexadecimal counter. So these are the types of counter which we are going to study in this particular unit. In this unit we are going to study this all types of counter and how to design this counter. So what are the application of this counter? The application of counter, the best example is what? Digital clock. Everyone, we are using the mobile, we are having the digital clock in the mobile, that is called as the counter. Time measurement. Next, A to D converter, when we want to convert analog to digital, then we require counter, because we have to calculate the number of pulses. Frequency divider circuit, suppose the frequency is 1 kilohertz, we have to make it half, then we have to use the counters once again. Then digital triangular wave generator, by using the digital counter we can generate the digital triangular wave. Okay, so let us summarize all the points. Obviously, sequential circuit cannot be designed with the memory, so sequential circuit requires the memory. The main types of the sequential circuits are the synchronous and asynchronous. This classification of the clock can be classified as age triggered and age triggering and level triggering. In that, again, we have a positive age triggering, negative age triggering, positive level triggering, negative level triggering. Okay, so, and digital counters are used to the counting the number of pulses. So we have summarized all the points. Hope you have enjoyed this video. In the next video we are going to design the 2-bit synchronous counter. First we will start with the 2-bit synchronous counter, then we'll go for 3-bit, 4-bit and n modulo counter. Okay, so I'm going to teach you how can we design the synchronous counter in the next session. Okay, with this, thank you for now. Enjoy your learning. Thank you.